Welcome to today's explainer. If you're a focused learner looking to truly master the advanced mechanics of decision analysis, well, you are in exactly the right place. Today, we're prying open a daunting, highly mathematical black box of complex decision-making. We're going to break down a powerful algorithm that handles the messy, often contradictory nature of real-world choices.
Okay, let's dive right into this. We've all been there, right? You're trying to make a massive decision. Maybe you're evaluating multi-million-dollar infrastructure projects, or maybe you're just picking a really complex software vendor. So you write up a pros and cons list. But inherent in that simple list is a massive flaw. Trade-offs just don't always reflect reality. Think about it. What happens when excellent performance in one area simply cannot make up for a catastrophic failure in another? Simple calculators completely break down when your criteria clash like that.
So to really understand our solution today, we have to contrast it with the standard tools you'd typically find in those web-friendly calculators. Standard methods like TOPSIS or the weighted sum model force compensation. They take your raw data, distort it through mathematical normalization just to make everything fit on the same scale, and then they let high scores in one criterion simply cancel out low scores in another. But our focus today, the ELECTRE method, is fundamentally different. It's non-compensatory. It actually embraces the messy reality of your data and allows for something incredibly human, the concept of incomparability.
Here is our roadmap for this explainer. We'll start by decoding complex decisions, define exactly what ELECTRE is, explore the power of thresholds, unpack concordance and discordance, look at distillation and final rankings, and finally, weigh its strengths and limitations.
All right, let's kick things off with Section 1. Decoding complex decisions, moving beyond simple pros and cons.
You might be wondering, why do advanced business analysts, data scientists, and engineers even need a heavier mathematical tool in the first place? Well, because the real world doesn't operate on perfectly smooth, comparable scales. And that brings us to ELECTRE. Now, this is a French acronym standing for Elimination et choix traduisant la réalité, which basically translates to elimination and choice translating reality. Originally presented by Bernard Roy back in the 1960s, this multi-criteria decision tool was built entirely around the concept of outranking options rather than just scoring them on some flat, arbitrary scale. It literally aims to translate the complex reality of human preference into rigorous math.
Moving on to Section 2. What is ELECTRE? The philosophy of outranking.
Now, what's really interesting about this is the underlying philosophy, because outranking is a very specific mathematical concept. This quote from Bernard Roy perfectly captures the essence of it. He states that an outranking relation exists when there are sufficient arguments to decide whether option A is at least as good as option B, and there are no essential reasons to refute this. You see, it's not about option A getting a higher total score than option B. It's about looking at every single criterion and asking, do we have enough evidence to confidently say A beats B? And just as importantly, is there any massive red flag in B's favor that completely stops us from making that claim?
Which brings us nicely to Section 3. The power of thresholds, designing pseudo-criteria.
To make this philosophy actually work mathematically, ELECTRE introduces this brilliant concept of pseudo-criteria. Honestly, this is where the method absolutely outshines simpler calculators. It asks the decision maker to define three very specific thresholds. First up, the indifference threshold. Imagine you're comparing temperatures. A difference between, say, 60 and 61 degrees is so small that you simply don't care. Mathematically, no strict preference exists. Second is the preference threshold. This is the exact mathematical gap required for you to say, yes, I strictly prefer this option over the other. And third, the veto threshold. This one is a vital failsafe. If an option performs unacceptably badly on just one single critical criterion, it is immediately vetoed, no matter how perfectly it scores everywhere else.
And this brilliantly illustrates what those dense parameters actually look like in practice. When you're using classic software for this, you have to input specific indifference values, usually denoted by a Q, and preference values, denoted by a P, assigned to all your different alternatives. It takes a lot of deep, careful thought from the user to set these parameters, literally translating their subjective, messy reality into exact numerical boundaries.
Okay, Section 4. Concordance and discordance, the engine of the black box.
Now that we've got our thresholds set, we are ready to open the black box and look at the actual engine of the algorithm. It basically builds a legal case for and against every single option, comparing them all in pairs. It's a clean, four-step process. First, standard matrix preparation and normalization. Second, it computes concordance. Think of this as gathering all the positive evidence supporting the claim that choice A is better than choice B across your criteria. Third, it computes discordance. This is the counter-evidence. Is there any criterion where choice A fails so badly against choice B that it hits that veto threshold we just talked about? Finally, in step 4, it aggregates all this evidence and counter-evidence into one global outranking dominance matrix. Moving right along to section 5, distillation and final rankings, creating the partial preorder.
So once the algorithm has tested every option against every other option, it has to spit out a final result. But unlike simpler tools that just give you a numbered list from 1 to 10, ELECTRE creates what is called a partial preorder. Let's see how this builds a final recommendation. The system actually runs 2 separate distillation processes, one descending from the best options down to the worst, and one ascending from the worst up to the best. It then intersects these 2 separate graphs to create a final combined graph. You'll notice it actually branches. Some options tie and sit in a single box while others branch off in completely different directions.
The reason for that branching comes down to how these options relate to one another. In ELECTRE, when 2 options are evaluated, the result isn't just a simple A is better than B. It can result in indifference, strict preference, or crucially, incomparability. This means the algorithm has looked at the data and concluded that option A and option B just cannot be fairly compared based on your criteria and thresholds. They have vastly different strengths that simply do not overlap. And honestly, this is a highly realistic outcome that basic scoring calculators completely ignore, which really demonstrates the true strength of the ELECTRE method.
Finally, section 6, strengths and limitations, balancing effort and precision. We've seen the power of the tool, but the crucial point is, what's the catch? Why isn't every web calculator using ELECTRE? Well, it comes down to balancing effort and precision. On the spectrum of multi-criteria decision analysis methods, ELECTRE requires a very high amount of effort compared to a simple ideal solution method like TOPSIS or a basic weighted sum model. Because it demands so many subjective preference, indifference, and veto thresholds from the user, building an intuitive UI or UX for ELECTRE is incredibly difficult. It's a dense, heavy mathematical tool, and it requires a highly informed user to operate it correctly.
And there is a mathematical vulnerability you absolutely must be aware of, the rank reversal phenomenon. Extensive computational testing has shown that if you're using ELECTRE and you decide to simply add or remove one alternative from your list of choices, the entire final ranking order of the remaining options can unexpectedly flip. It's a strange quirk of the complex paired comparison math, but it proves that even the most advanced systems have their blind spots.
Which leaves us with this final thought. We use tools like ELECTRE to translate our messy, subjective reality into rigorous, impartial math. But if a sophisticated algorithm can still suffer from phenomena like rank reversal simply by introducing a single new option, can mathematical precision ever truly replace the adaptability of your own human intuition? Or are these tools really just mirrors, helping us understand the parameters of our own judgment? Think about that the next time you're facing a massive, complex decision. Thanks so much for joining me on this deep dive into the explainer, and keep learning.